Okay, now let's take a look at how satellites work. And basically we'll start out with our projectile motion. So with projectile motion, if we started out with a small velocity, then we'd have this parabolic motion and it would come back and hit the ground again. If we started out with a larger velocity, then our projectile would go farther, still following a simple parabola. Now, if we were to take that same projectile motion, and instead of having it go at an angle up, we just shot it out horizontally. Okay? Then again, we would have it go for a little while. If we shot it out faster or at a higher velocity, it would go a little farther. So now think if we were on a very tall mountain on the Earth. Okay? We could shoot it out and it would go pretty far. Shoot it out a little farther, go a little farther. Shoot it out even faster, it would go even farther. And at some point, we could shoot it out fast enough that would actually just keep going and come back to the spot where we shot it out at. Okay? And if we shot it out faster than that, we could actually get it to go and just keep on going. Okay? So when we get something in orbit around the Earth, it is actually the velocity that or the speed that the satellite is going that keeps it from coming back down. Okay? It's going fast enough that as it falls towards the Earth, which it's always doing, the Earth is curving around again. Okay? Now I have a little flash that shows this. What we have is maybe the sun and the Earth, or the Earth and the moon, or an Earth and the satellite. And right now these numbers down here don't actually have any units to them, so we just can vary them and see what happens. So we have our ball or our particle going at a small velocity above some mass. Okay? Now it's not going fast enough, it just crashes down to, in this case, I guess the sun. So let's increase that velocity a little bit. And again, it goes a little farther, but still crashes down. And let's try 40. And almost makes it around it. Let's see what happens at 50. Oh, crashed again. How about 80? Okay, now we just missed it. And it goes around. And as we'll talk about later, it goes around in a little ellipse with the sun here as one of its foci. Okay, I think let's try about 100. Get more circular. And how about 150? Okay, so a little bit more circular. And let's try 2. So at 200 it goes way out there, and I guess at 200 it'll probably come back. If we go a lot higher, then it's just going to go flying off. Okay, so it's actually the speed of the satellite that keeps it from falling back to the Earth, to actually crashing back into the Earth, and that's what keeps the satellites up.